At the end of the previous section, you were accepted for the position of engineer. Your first assignment is to prepare a model for a robotics-based electric car manufacturing system. The CEO of your company is eager to see the result. To get you started with your modeling assignment, let's watch these robots. They are performing hosting tasks to help celebrate the new year with the Technion's president. So let's model this system. The first step in modeling a system in OPM is to describe it so all the stakeholders can understand what the system is for and what it does, even if they lack domain expertise. This will help us communicate the system's function, structure, and behavior to managers, customers, suppliers, and experts from other fields. Your CEO is also expecting to see a model of a robotic system for manufacturing electric cars that is simple and easily understood. What we have just seen can be described as a system for picking, transporting, and serving fruit. In OPM, the overall description of the system is expressed in the first OPD we create, called the System Diagram, or SD for short. SD aims to provide all the stakeholders with a top-level, bird's-eye view of the system, focusing on its function and the benefit it delivers. It therefore must be simple and clear, with minimal technical details. SD has 5 components: purpose, function, enablers, environment, and problem occurrence. The first component is the system's purpose. Who are the beneficiaries, the people for whom the system was developed? What benefit does the system provide to them? In our case, the purpose of the system is to provide people with fruit effortlessly. The second SD component is the system's main function. What is the main process and the object it transforms that together deliver the benefit? Our system picks, transports, and delivers fruit. In short, we can therefore call the function fruit providing. The third component, enablers, includes the objects that enable the system's main process, allowing the system to operate. There are 2 kinds of enablers: agents and instruments. Here, the instruments are the robots, the tablecloth, and the plate. Agents are always people. In our system, they operate the robots. The fourth SD component is the system's environment. What things, objects, and processes are not part of our system, but still affect its operation? Here, we include the fruit trees and the robot's transportation path. We can also include processes such as wind blowing and rain falling, which can also affect the system's operation. The fifth and last SD component is the problem occurrence. Any artificial system aims to solve some problem. In our case, people are hungry and want to eat fresh fruit without having to leave their seat. The Technion's president who benefited from the system is an example of someone for whom we would usually present only the system diagram, SD, with its 5 components. Your assignment is to present your CEO with the SD of the robotics-based electric cars manufacturing system. So, let's order flight tickets to get to the robotics lab and take the opportunity to model the SD of the flight tickets ordering system. Unlike the system we modeled before, which was physical, this system is informatical, as it focuses on ordering flight tickets rather than actually flying. The system's website allows us to easily and quickly find and order flight tickets. The system's purpose is thus to shorten travelers' time and improve their convenience of finding flights and ordering tickets. The function of the system is to change the status of a seat in a flight from available to purchased. The enablers include the agent of the main process, the traveler, and the instrument, the website. The environment includes internet connection, which is also an instrument of the main process. Finally, the problem this system solves is the difficulty of finding flights and ordering tickets. Let's summarize. When modeling SD, we represent 5 system components: purpose, function, enablers, environment, and problem occurrence. Using the online flight ticketing system, we now have tickets for our flight, And in the next video, we will meet at the airport.
The system diagram, SD, defines the system's purpose, scope, and main function in terms of its main object, main process, boundary, and stakeholders. SD aims to provide all the stakeholders with a top-level, bird's-eye view of the system, focusing on its function and the benefit it delivers. It therefore must be simple and clear, with minimal technical details.